The Heisenberg's uncertainty principle seems to tell us that the real universe begins where time ends. However, this uncertainty of the position or speed of particles, governed by time, would sustain our memory. So, when it comes to our point of view, the end times would be a trend that would have been suspended to infinity. When physicists use the limited speed of light to gauge time, they allow themselves to place the zero mark of their count at the position of the star that would have emitted that light. This would be a form of abstraction, since the events that were taking place in our future would not yet have happened, for all intents and purposes. Given the limited speed of light, and believing its waves to be continuous, why not extrapolate this measure of time towards our future? For example, counting from the position of Beta Andromeda, light from the star should take 75 years to reach Earth. In the case of its abrupt death, we would have to wait that long before we would learn of the event. That is, the star's death would be confined to the interior of its future light cone. That's why it doesn't exist for us yet. Because of the wait, the counting of time will start from our position on Earth, as we need to wait for the information to arrive. Despite the delay predicted in theory, for our point of view, the manifestation of the event of the death of the star would be instantaneous. The suppression of the direct record of time in our future would be related to the apparent inversion of its arrow's direction in our present. When we become aware of future events, we are already looking back in time or to our own past. In fact, the arrow of time remains unchanged and continues to point towards our future. Fixing the zero point of time in our position and the consequent reversal in the direction of the time arrow is of great importance for our subjective assessment, especially when it comes to determining the real sense of the forces acting in space-time. The current view of cosmology predicts that massive celestial bodies, such as stars, would be able to generate gravity directly. That is, gravity would result from a change in the geometry of space, caused by its masses. This would be acceptable if the space could directly communicate these changes in its structure, which does not happen in practice. To do this, space would depend on a messenger, represented by gravity waves. These waves need time, resulting in delayed communication of distant events. When the observer becomes aware of gravity, he will already be living with the apparent inversion of the arrow of time. This would have to be taken into account, as it would explain the mysterious action of this force, which, according to Newton, would act instantly and at a distance. Under these conditions, gravity would become a force of a secondary or restorative nature. Before the manifestation of gravity, and by principle of exclusion of direct access, there was an information vacuum virtually placed in our future. This emptiness would have created a predisposition in space for the attraction between celestial bodies, a movement that would turn negative, as if time imploded in our future. It is easy to notice the theoretical difficulties that arise when trying to support the theory of relativity's claim that the massive stars would be able to bend space directly. This thesis results from not attaching the slightest importance to our points of view. The universe does not depend on what we think about it, but our assessment of the sense of forces does. When we think about space and its messenger, cosmic radiation, we cannot separate their behavior. So much so, that physicists attribute to space the same harmonic behavior that characterizes light. It is foreseen in the model of the mass spring assembly. It is said that space would be able to stretch or contract in an exclusive way, as with a rubber band. In the visible universe, potential energy, which accompanies the spring of space, is always negative or attractive. The spring would always be contracting, and the potential energy would always be decreasing. According to the aforementioned model, if space or the spring were to stretch, as predicted in the expansionary phase of the universe, an increase in elastic potential energy would be expected, rather than a fall. That is, there could be no acceleration of the movement of galaxies if it resulted directly from the increasing curvature of space. Like, for example, the one associated with a Big Bang singularity. In the expansionary phase, the force would always point in the opposite direction to the stretching of space, with an increase in elastic potential energy. This energy comes when you stretch a rubber band. In that case, galaxies would tend to collapse, sooner or later. The universe would decay to its static state, and time would cease to exist. The solution to the problem would have been the displacement of the zero ground of time to the position of the isolated observer placed in the present of the universe. This thought denotes a certain cosmic intentionality. It is as if the uncertainty in the position or speed of light sources put the previously static universe in continuous and relative motion. Uncertainty would not subsist outside of the observer and his points of view. Thus, it would not be very relevant to think of the 13.7 billion years it would have taken cosmic radiation to travel through the vacuum until could occur the apparent inversion of the arrow of time in our position. Only when it could be traced back to our past could this radiation be considered background. Due to the obvious ability we have to do this tracking instantly, it can be said that the light has always been at our entire disposal in the present, and can only be followed in the direction of our past. It's just that the future has become inaccessible to us. By excluding direct access to information, which might be related to future events, one can think that time would have gradually contracted, following the stretching of space, in the expansionary phase, until the time could reach subliminal levels, in our present moment. That is, the contraction of time could not be total, because, at least when it comes to our memory, it is necessary to conserve the curvature of space and the uncertainty in the position of distant light sources. Otherwise, the universe would be static. This means more or less the following. The elastic potential energy, which would accompany the expansionary phase, could not be maximum at infinity, as it would be limited by time. The collapse of the universe, in this case, would be prevented by the contraction of time to subliminal levels. This problem would be related to the observer and the apparent inversion of the arrow of time in its position, a detail that would not necessarily be extended to the universe. It is that our memory could not register events that happened outside of measurable time. The contraction of time takes us to the subatomic level of matter, where, in order to be described, particles must first be illuminated. This requires shorter and shorter wavelengths. The light waves used by the quantum system operator are time-dependent. That is, without time, there is no movement. So, even being there, many particles cease to exist, because they cannot be detected. Within our observable universe, space appears to contract continuously, followed by a drop in potential energy and acceleration of movement. For physics, the potential energy would be nil at infinity. There would be no place for the existence of an expansionary phase of the universe, as it predicts a continuous increase in potential energy. In space-time, the spring of space would start from its resting position, in which there would be no forces acting. From there, the potential energy would decay, as the distances between two bodies that attract each other were reduced. Meanwhile, time would continually stretch towards our event horizon. Many scholars on the subject have already concluded, by observing the night sky, that the universe shows a tendency to flatten, with increasing astronomical distances. What once seemed absurd, now points to the existence of a stationary universe outside of time, that can be measured directly. Direct observation of this type of stationary universe is impossible, because our memory would be linked to the measurability of time. This also happens with movement in space-time, which becomes continuous and relative. Here, there is no absolute movement. When the observer becomes aware of the reality around him, he would already be putting himself outside of it, looking directly at his own past, which no longer exists.